All right, everybody. So today we're going to have a really short video, but we're going to learn some pretty powerful things in this video. We're going to look at how to make truth tables for arguments, because remember, logic is the study of valid inference, and a valid inference is one in which if the premises are true, then the conclusion must be true. When you have an argument, you have some premises, and then you want to infer some conclusion, and we want to know if that was a valid inference or not. So for example, I have this argument right here. If Johnny goes to the store, then he will buy eggs. Johnny did not go to the store. Therefore, Johnny did not buy eggs. So I have my premises that and Johnny is I, so if I go to the store, I'll buy eggs. I'm also given that I did not go to the store. So I want to conclude that I did not buy eggs. But is that true? Here's how we would find out. So the first thing we want to do is take our statements and symbolically represent them, right? And we know how to do that. So if Johnny goes to the store, then he'll buy eggs. That becomes J, then E. Johnny did not go to the store. Okay, well that's not J. And then my conclusion, so I'm going to separate my conclusion from my premises with a horizontal line, like this. Therefore, Johnny did not buy eggs. Okay, so I want to say not E. So there's my symbolic representation of the arguments. My premises are in blue, my conclusion is in pink. But now we want to construct a truth table for this. So let's do that. How do we construct a truth table? Well, we'll write out our parentheses, right? Not our parentheses, our premises. And what we have to do is separate our premises by one diagonal line. So J then E, not J. And then we separate our premises from our conclusion with a double diagonal, so like this. So that's separating them, and then our conclusion is not E. And now what we have to do is complete the truth table. And if on any line we have a situation where our premises are true and the conclusion is false, then this is an invalid argument, is an invalid inference. Otherwise, the argument is valid. So let's do our truth table. All right, so let's assign T, 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 T. Then we'll have T, F, T, F. We'll go F, T, F, T. And then finally, F, 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 F. So let's look at our first premise, right? If J, then E. So true then true, that's true. True then false, that is false. False then true is true, and false then false is false. Now let's look at our second premise, not J. Okay, well, not true is F, not true is F, not F is... Hold up. Yeah. Not F is true, and not F is true. There you go. I'm just double checking to make sure I fill this out right. Cool. And now let's do the truth for our conclusion. So for not E, so not T is F, not F is T, not T is F, and not F is T. So now let us look at the truth value of our premises. Let's highlight this with blue. There we go. Here it is. Everything under the main operator. And then the truth values for our conclusion. So on the first row, we have a true, false, and a false. Okay, so that's whatever. Next, we have a false, false, and a true. And then on the third line, right here, we have true, true, and false. So we found a situation where our premises are true, but the conclusion is false. So since that's the case, my argument, J then E and not J, implying not E, that's a false argument. I cannot imply that because we had a situation where the premises were true and the conclusion was false. And let's kind of think about this like logically, without the symbols in English, right? I was saying that if I go to the store, I'll buy eggs. And also, I did not go to the store. And so I wanted to conclude that I did not buy eggs, but that's not always the case, you know? Sure, if Johnny goes to the store, he'll buy eggs. And sure, I didn't go to the store, but maybe I bought eggs on Amazon, right? I didn't go to the store, I just stayed home and bought eggs. So that was the situation where the premises were true and the conclusion was false. Does that make sense? I hope it does. Because that's pretty much all there is for this. I mean, there's a ton of exercises you could do on your own by translating arguments from English to our symbolic representations and then doing truth tables. But yeah, There you go. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.